Hi again. This episode is called Debodgification. Uh, Basically, when you're working with something that somebody else has done before you, you're bound to find things that are not correct or need amending, need changed, and all the rest of it. I think I mentioned this before. It's just part of the process of doing this. So what I thought I'd do today is look at some of the methods that I use to fix things that are either errors or just different from what I want to do on the engine. To be honest, this is principally about filling holes in this episode, and I'm sure there are going to be further episodes like this down the line that look at various other aspects of changing things, debodgifying things that are not quite as they should be, not to mention the repairs, the mistakes that I am bound to make myself. So with that, let's get on with it, and I hope you enjoy this episode. Thanks. So, plan is here to try and jack these frames apart in order to pull this out with the remains of the tap still sticking up. If we can do that, then it's going to be far easier to get that tap out of that cast iron. I did have a look at undoing these, but managed to break or ruin the ends of two Allen keys trying to do that. They just will not undo. So potentially, I just strip the end of the key. Potentially these have been Loctite in, and the only way of dealing with that is to get it really hot. I don't really want to do that to try and solve this problem. So literally I just made it up. It's an M10 bolt which I've faced off the end of, a piece of scrap which I've put an M10 thread in, and a bit of a knurl, not a very good one. I'm going to use a spanner to try and jack this up and see what happens. And the idea is to try and do this without causing any damage to the frames. Okay, so alright, what I'm going to do is put a spreader in, because I can see what's happening is that the frame is distorting shy of this hole, and I don't really want to bend it. So let's find a piece of metal to stretcher. The bigger the lump of metal, the more stretching, the more spreading it's going to be able to do of the load. Actually, I need two. That's me in position and finger tight. Now I'm going to watch very carefully as I'm doing this, make sure nothing gets unduly distorted. Is get rid of this as fast as possible. And let's get a square and nothing has got improperly bent. Looks like it is still flat, and that side the same. Okay, that is a quick rescue. Now I just need to get that out without it crumbling anymore. So it feels a bit loose. Try a pair of ordinary pliers to start with. My God. What a relief. So, broken tab out, stretcher out, frames out. Now the next job to do is to see what I need to do about machining this here. I've spent a bit of time measuring and marking this up just to see what the implication is, because it looks an awful lot like, to get the 5/8 there, I'm cutting into these bosses which are supposed to support pumps. Not very happy with this outcome, to be honest. I think the casting could have been better. And also I'm not sure about the dimensions. I need to check the dimensions again against the drawing. Alright, so that's a good rescue today. I need to fix the threads in here and in here. That's coming through. Those ones aren't. Yeah. Well, some castings are better than others. This one seems to be a bit of a lemon. However, onwards. So the next challenge is to fill in the extra holes here, and it's already evidence of this having been done there and there. So the way we're going to do that is we're going to figure out what size these holes are and put the next nearest size tap down them, put in a bolt or a piece of old thread, cut it off both ends, and then stick it in with Loctite, and then cut off the ends flush with the chassis and sand it or file it flat. So what I've got is my set of number drills. Let's just grab one that I think looks right, and that's just a little bit too tight, so that's one down. Yeah, so that's a number 34. Let's make sure the other ones are going to be the same. Yep. 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 Something in that one. That's all the same, 34s. What we'll do is we'll get our magic chart of sizes. I got this last year at the Model Engineering Exhibition from Walter Midgley, well-known insurers of model engineers. So what we're looking for is, what is 34 a tapping size for? That's dead on. So let's just measure this again. 764, so go to 2.78 millimeters. So if we want the metric size, 2.75 millimeters is M3. Looks like we should try tapping these M3, and that's going to be the closest size. Do one and see how that feels. Metric taps. looks to be what I want. M3 taps, and I'll grab my nice little tool for these. A box of M3 screws. Miscellaneous. Be as square as I possibly can be. It's cutting nicely. Doesn't matter what the head is, it's going to come off anyway. Perfect. Once I've done this side, I need to do the other side exactly the same, so I won't bother showing you that. What we'll do is we'll put these in, find some screws, get the Loctite out on them, let it set off, and then finish off the resulting mess. And oh dear, the compressor joins in again. Right, let's put these out the way. So Loctite has different flavours for different things. 638 and 602 are both relatively high strength. I think 638 is the more sticky of the two, so we'll use that. This is really for things that are going to go in and never come out again. Don't use it on something you don't want to dismantle, because you will be heating it for ages. And somewhere around I've got some cleaner specifically for this job. In lieu of that, I will use brake cleaner. Aerosol brake cleaner really doesn't matter where it comes from. This says Parkside, so it came from Lidl. All you're looking for is something that's a clean solvent. We'll take all these out again. Spray down. Another good air blast to clean it out again. What I'm going to do, simply one of my fingers, is I'm going to put drops of this stuff in each of the holes I want to fill. screws in so I can feel them on the other side. You won't be able to see them on the other side because the stretcher will be on top of them. The outside needs to be, that's going to be visible. Right, that will take an hour or two to set off, so just leave it until it is fully hardened. In the meantime, I'll flip it over and do exactly the same side on the other side. Okay, so these have now been, this is the other side from the side we looked at before. These have now been in for overnight, so time to chop them off and clean up the ends. So we have 3 abbreviated screws which go back in the bin because they are going to come in handy for something else later, I am certain. Right, so slightly proud ends. Let's use Dremel substitute with a drum sander. I think is the right tool for this. Now, these little ones are now very cheap from China or from Aldi or Lidl or somewhere like that. Drum sanders also very cheap. I'm just to try and keep this as flat as possible. That's what happens when you don't tighten it up enough. Let me go find it. That claps you in the face, that's not funny. It'll be tight this time. Nobody would ever know the holes were ever there. Well, yes they would, you can see them and you can see the previous errors. Now I've cleaned the paint off as well, but a coat of paint will tidy that up. Let's just clean this up a little bit. Yeah. Well, that's pretty good. There's a lot more errors there. Now I've cleaned the paint off that you could see before. Painting that over will get those to disappear. So just have to do the same on the other side and then we're done with this repair, I think. Let's just do that, see what happens. No. So what happened was, as soon as I brought the drill down, it jumped over towards the hole that we don't want to use. Not ideal. Maybe the better job would be done by plugging this bar and then re-drilling it like that. Okay, so that's the end of this job for today. What I've done is I've taken this out now, and what I'm going to do is I'm going to make up those holes with a bit of brass and a brass screw and soft solder, just so that I can try and get a better drilling through, because the first one went a bit askew and it's not good. Right, so I've used a bit of flux on the joints. You can just see the flux there, and just a bit of brass wire. I'm going to cut it off to suit, and this screw is 4BA. It's been tapped and screwed in. I just want to fit it in and I can chop it off and make it neat. So I'm using good old-fashioned RS Components 40-year-old lead and tin 6040 resin flux solder. Okay. This side's done. Plenty of flux. Right, so it would be possible to silver solder this as well. I don't think it's really necessary for what we're trying to do here. Just literally fill up some holes in order to be able to get a drill through that's not going to wander anywhere. So here we go again. Right, let it cool. And we'll come back in a minute when we're putting it back on the engine. Okay, I had a little incident with this. What happened was I thought these parts, which go underneath here, were silver soldered on, and I proceeded to hold it by these to start machining these pockets, and I got all the way through to the last one, and it gave way, it went flying. It got the cutter marks across it because these were actually only glued on. Can't really tell that sort of thing. One has to make assumptions. So I've got another problem now to solve. So the way this is going to get fixed is by draw filing. So it's just basically taking a file like this and very gently rubbing it up and down, and we're not going to get rid of all those marks. They're too deep. But at least what we do is we get a surface that's going to fit, and there's a fitting surface because it goes underneath the pump cross member. So it just needs to be flush. It's amazing how good fingers are for determining how good something is, how good a surface is. So let's take a little bit more off, and I'll just actually do the whole thing so that it all looks coherent. We also find things like we have slight burrs on some of the other holes still. So the technique's called draw filing, and it's great for fixing small marks, damages, and to restore a surface. You do it properly, all the machine marks are going in the same direction, so it looks mint. And finish up with a bit of Scotch-Brite. Won't get rid of all the filing marks, but it'll shine it up a bit so it looks proper. Make sure when you're doing it you don't have any things like that in the Scotch-Brite, because that will cause a scratch. That means you have to do it a bit more. Right, so those are going to get hidden, thankfully, but the rest of that looks quite smart. Oh dear. Then you have to make the rest of it look smart too. Again, who's going to see this? Oh, another little ding. Didn't know about that one. It's amazing how things disappear when you put them down. Okay, still marks, but you can't feel anything. Can't feel anything there. Great. So that's that finished. I'll just assemble this and we can have another look at it. Okay, so that is it back together again. The thing is, when things are subject to rapid unplanned disassembly, especially things like this, getting all the bits back in the right place, in the right order, in the right way up is sometimes more challenging. But the answer is just to bear in mind, if it doesn't go together right first time, keep putting it together until you find the way it's supposed to go together. Now at this point, that is getting a bit tight here. There's loose there. I don't plan to actually do anything about that just now because I'm going to be remaking these crossheads. When I remake the crossheads, I will determine what the problem is